So this is part 2 of section 2.6, composition of functions. And really a composition of a function is taking one function and putting it literally inside the other function. And so here we are taking this function and plugging it in for x here in this function. So that's why it becomes x plus 1 squared. And it is read as f of g, or f composed with g. So when you take the take the composition of one function, usually it's written like this. And if you rewrite it like this, it kind of shows you that g of x is literally plugged in for f. So continuing on, let's look at this as an example. We have f composed of g, x, and here's our two functions. On this one, I'm going to rewrite it as f of g of x. And I know that g of x is literally going to go inside of f of x. So I am putting a box here for my x plus 2. Pardon me. Oh, I had a sneeze, but it didn't come out. Okay, so 4 minus x squared will go in that spot for x. So I'm going to simplify this. This will be minus x squared, and then 4 plus 2 is plus 6. You can go in the other direction, g of f of x, and this time I'm going to say 4 minus, and then I'm going to put a little box here, and that's going to be squared. Inside this box will go the other function, so it's x plus 2. I need to square that function, so 4 minus, once you square it, it is this. That negative has to go to everything, remember? So this will be 4 minus x squared minus 4x minus 4. And so finally it will be this, because these will cancel. Lastly, we're going to plug in negative 2 into f first, and then plug that in to g. So this will be f of negative 2 is negative 2 plus 2, which is 0. So then I'm going to plug that into g. So it'll be 4 minus 0 squared, which is just 4. Here's an application problem. We have bacteria in refrigerated food, and this is the number of it, and it's given by this equation, between the temperatures of 2 and 14, and that's in Celsius. When the food is removed from refrigeration, the temperature of the food is given by this. So T is in time of hours. Find the composition of N composed T and interpret its meaning in context. So when I'm composing this, I'm literally putting this equation in for T here and here. And that is what they did here. And then you need to simplify that out. So this has to be squared. So that becomes that. And they distributed the 80. And that's what became here. And then distributing this is here. And finally, adding like terms. So there's nothing that goes with 320t squared, but the 320t here cancels out. And then if you add these together, you get 420. So the composite function n of t represents as a function of the amount of time the food has been outside of the refrigerator. So as time goes on, how much bacteria is growing in this food? The bacteria count will reach 2,000 when this equals 2,000. So that's what we just found, was this function. So we're going to set it equal to 2,000 and then find t. Once you do that, we're going to subtract 420 from each side, and you get 1,500 580, and then you divide by 320, and then you're going to take the square root of that, and you get about 2.2 hours.